Hey everybody, it's me, your favorite teacher, Mr. Baldwin, and I'm here at the beautiful University of Tennessee right here in Knoxville, right in front of Ayers Hall. I'm getting ready to speak with Dr. Sean Lindsay, a teacher here, a professor here at the University of Tennessee. And we're going to talk about the upcoming solar eclipse in Sweetwater. So, stay tuned. And here we are, I'm here with Dr. Sean Lindsay at the University of Tennessee. Dr. Lindsay, thank you for agreeing to talk to us about this today. And why don't you tell all our great people of Sweetwater a little bit about yourself, if you would. For example, what do you teach here at the University of Tennessee?
Well, I'm Dr. Sean Lindsay. I work here at the University of Tennessee as the astronomy coordinator in the physics and astronomy department. So that means that I teach our introductory astronomy courses, everything from getting to know how astronomers take observations, how we collect data, how we understand the universe itself, to actually going through and understanding and exploring our solar system, then moving out to the stars, to galaxies themselves, and then the largest structures of the universe in a study of cosmology.
Wow, that's some very heady stuff there. In layman's terms, you're talking about planets, stars, space stuff.
Yeah, I mean, space stuff is a great thing to talk about, and really one of my favorite things to always talk about is star stuff. Like, we are all star stuff, as the late Carl Sagan said. Stars generate all the matter of the universe other than hydrogen and helium, so all the atoms of the universe come from stars themselves, and then eventually through planet building and solar system building to the evolution of life, we all end up where we are made out of that star stuff right here, right now.
Excellent. So I see that you're wearing an eclipse shirt, which is what we're here to talk about today, the great eclipse of 2017. Now, earlier we were messing around here with this beautiful sun sphere in the background where we had prom in 2013. And could you explain what you were doing with the lens cap on that?
Yeah, so I was holding up this lens cap earlier to cover up the sun sphere perfectly. Basically, I was going to be eclipsing the sun sphere. So one of the reasons that we are able, and we are lucky right now in this time in Earth history, to observe eclipses is because the size of the moon in the sky is nearly exactly the same size as the sun in the sky.
That sounds like a pretty rare occurrence.
It is a rare occurrence, and Earth is the only place in the solar system where you can get a total eclipse like we do.
Wow.
So it just so happens that the sun is about 400 times larger than the moon, and the sun is about 400 times more distant from the Earth than the moon is.
Okay.
So that perfect alignment right there makes it so that the moon in the sky is exactly the same size as the sun in the sky. So if we get the geometry right and we can have the moon pass directly in front of the sun, that is when we observe a total solar eclipse.
And that's what
I was
we're
trying
going
to do with the lens cap.
And that's what we're going to see in Sweetwater on the 21st, correct? We're going to have totality, is that correct?
That's exactly right. In Sweetwater, one of the best places in the country to observe this total eclipse, you will experience totality. So that means that the disk of the moon will pass perfectly in front of the disk of the sun, blocking out all of the light of the sun except for the outermost atmosphere of the sun. This part that's called the corona of the sun. So whenever you see eclipse shirts, you can see this kind of white glowing light right here.
Mm-hmm.
As the moon covers up the sun, we get the rare opportunity to observe this part of the sun called the corona. It is this white, glowing, soft light. It's absolutely beautiful. In every eclipse, we get a unique view of what the corona looks like. And if people are talking about what science will be done during this eclipse, a lot of it involves studying the corona of the sun.
Okay. Now, very briefly, what can you tell us about the corona of the sun as far as research capabilities? What kind of things are they trying to research? Are there energy opportunities there?
So they're
to harness that energy.
There are a few main things that they're really looking for whenever they're researching the corona. During an eclipse is the only time that we earthly denizens can actually see the corona, and it just so happens that since we are observing the corona from the Earth and the moon is just the right size to perfectly cover the sun, it's one of our only opportunities to see the inner part of the corona. Okay. This is really, really hard to do with spacecraft, which have special instruments that block out the light of the sun and can study the corona 24/7, 365.
Okay.
But they cover a little bit too much of the sun and they can't really observe the inner part of the corona. So that's what a lot of people are going to be looking at. Okay. One of the big questions that's remaining out there, if you go to the surface of the sun, it is really, really, really hot. Not a place you'd like to be. You'd be vaporized into atoms instantly.
Okay.
We use the temperature scale Kelvin. So the sun's surface is 5,800 Kelvin. The corona, however, is mysteriously over 1 million Kelvin.
Wow.
Much, much hotter.
Is that the hottest thing that we can think of?
We can think of a lot of higher numbers. In fact, as mathematicians like to say, 1 million is a really big number, but it's smaller than most.
All right, Dr. Lindsay, one question that we often have is, why do you have to wear these glasses, these special glasses, available at City Hall and right here at Sweetwater High School, for this solar eclipse event of 2017?
Right, so to safely observe the solar eclipse, you need to have eclipse glasses. So these are special glasses that are designed to remove a lot of the sunlight.
Okay.
In fact, they only let 1/100,000th of the sunlight through.
Okay.
So anytime you're going outside and you want to take a look at the eclipse as it occurs, you need to first put your glasses on, and then you can safely look at the sun.
Okay, now, I want to get a better view of the sun. Can I use binoculars while I have those on? I want to see all this corona I can see.
Absolutely not. I actually get this question quite frequently. While you can just look at the sun all day long while you're wearing these glasses, the one thing you never ever want to do is think that you can first pass the light through binoculars or a telescope and then wear the glasses and look through those binoculars or the telescope, because you're focusing the sun's light and it's pretty bright. We all played with magnifying glasses as kids, and maybe you set some leaves on fire. The exact same thing happens with the lenses in a telescope or binoculars.
So what are they going to set on fire? Some leaves, some grass?
It'll set fire to your retina.
Okay, well that's part of your eyeball and we don't want to do that.
Right, just looking at the sun naked eye, that can cause permanent eye damage within seconds. Luckily we have the automatic response. We sense pain and discomfort, so we automatically look away. During an eclipse, whenever the moon is covering up the sun, it won't hurt that much to look at the sun directly, except there's still enough sunlight to cause permanent eye damage. And that's why eye safety is so important to discuss during an eclipse. It's quite obvious to not go outside right now and stare at the sun. It'll hurt and you know you're going blind. During an eclipse, however, it becomes much more dangerous, so anytime that's not totality, you need to make sure you're wearing your eclipse glasses. Once totality starts, however, you can safely take your glasses off, and in Sweetwater you'll enjoy a little over 2 minutes of being able to watch the eclipse directly.
That's pretty cool.
And that's the most exciting part.
What are some things we can expect to see with this eclipse as far as when we're actually looking at it?
So there are a number of really, really cool things to take observations of while you're waiting for the eclipse to first start and then during totality. So just as it's nearing totality, those last seconds, whenever the moon is just not quite covering up the entire bit of the sun, just a tiny little fraction of the sun is exposed, it'll be really, really bright, and then you'll start to see the corona around the edge of the moon. We call this the diamond ring effect because it really looks like the moon-sun combo has turned into this diamond-like ring.
Okay.
And you'll also notice right then that there'll be these little beads of light, sometimes red in color, near the edge of the moon. These are called Bailey's beads.
Okay.
And
so those aren't aliens, those are Bailey's beads.
Those are not aliens, those are Bailey's beads. Okay. And they're caused by the fact that there's mountains and valleys on the surface of the moon and sunlight streaming through those valleys.
Do you think it'll be cloudy on the day of the eclipse?
So historically, it's predicted that East Tennessee on August 21st, historically 60% of those days are cloud covered.
Okay.
That does not sound that great. It gives us a 40% chance of clear days. However, the most recent predictions for eclipse weather put East Tennessee as looks good. Of course, being people that live in East Tennessee, we know that the weather around here changes at the drop of a hat.
Absolutely.
So hopefully the looks good sticks around and we will have perfectly sunny skies for the eclipse.
If it's not sunny, will we still be able to see the eclipse?
So if it's not sunny, everybody thinks that it's a total loss. It's not a total loss. Of course it's going to be unfortunate. You won't be able to see the amazing things like the corona of the sun.
Right.
And if it's really behind clouds, like if it's a rainy day and you can't see any of the sun, you won't be able to see the eclipse occur. But that doesn't mean the eclipse isn't happening. And I know a lot of cities, and I think Sweetwater is one of them, have agreed not to turn on street lights during the eclipse.
That's correct. We'll be shutting down power in the city.
So imagine how dark it is on a moonless night when there's clouds in the sky.
Still, that's pretty
It's
dark.
really, really dark. So
Yeah.
even if it's a cloudy sky, you're gonna go outside, and during the eclipse, all of a sudden it's gonna be just like a stormy day, and you're gonna be plunged into pitch darkness.
Wow.
It's so dark that I wouldn't walk around confidently without stumbling into things.
Okay.
So that'll still happen, and it'll last for about 2.5 minutes, and then the eclipse will be over and it'll start to get bright again.
Okay.
So it's not a total loss. It'll still be pretty exciting. Less exciting than seeing the corona, but everybody thinks that it'd just be a total loss, and I'd really, really like to encourage people, even if it's cloudy and or rainy, still get out there during the time of totality.
I'm again here with Dr. Lindsay. Now, Dr. Lindsay, you have seen an eclipse before. You've seen totality before. Is that correct?
That is correct. So I went to Svalbard, near the North Pole.
Did you see my good friend Santa Claus?
I tried to find Santa Claus, looked around, went to this polar bear's cave, went into an ice cave. Okay, I did not go into a polar bear's cave, but I went into an ice cave. No Santa Claus.
Did you drink a Coca-Cola with a polar bear?
No, no.
Did you think about it?
I probably would have tried, but I wouldn't be standing before you right now if I would have done so.
And
but it would have been a sweet video.
It would have, and you wouldn't be informed us about the eclipse of 2017. So you've seen one before, and you say, we were talking off the record, and you said it was an outstanding, it was a life-changing experience. Is that accurate?
Yes, and I'll tell you a little bit of the story of why I came to realize that it really was a life-changing experience, because these are things that just sort of happened to you. I knew it was going to be amazing, but I did not yet know how amazing the event was going to be. So there we are, we're out there. I'd seen partial eclipses, I'd seen an annular eclipse. So out there on this giant ice field, the eclipse starts, and that's basically the same as watching a partial eclipse. And as it got closer and closer and closer to totality, I could feel the excitement going. It was getting darker and darker out, but I did not know what I was in for. Because as totality sets in, it is an entirely different experience. And this is why I tell everybody, if you're just outside the path of totality, do everything you can to get to where you can see totality, because it is literally a night and day difference from seeing a partial eclipse.
By literally night and day, you mean it's going to be dark like night?
It's going to be dark like night. So as totality set in, as we're able to see the diamond ring effect, and then go into totality where we could see the corona of the sun. This is actually a picture that I took while we were up there, and this is a picture from totality.
Okay, so this one in the upper left, right there, that's what totality is going to look like.
That's what totality looks
just like on the front of all these shirts, just like on the front of your shirt, just like the front of my shirt, but I'm not turning the camera around. Okay, go on.
So as totality sets in, that's when you see the largest change in the amount of light. And it will jump from a kind of setting into twilight just before totality to the very darkest twilight you can imagine, almost complete nighttime. I could look up and I could see Venus.
Wow.
You can see bright stars. On this eclipse, you should look for both Venus and Jupiter. And if you got a sharp eye, you'll be able to see Mercury, which very, very few people have actually seen. It's estimated that only about 1 million people that live on this earth have ever actually knowingly observed Mercury.
How can you got any pointers on that one?
It's be really close to the sun, it'll be a bright point of light.
Okay.
Look up online exactly where it'll be oriented relative to the sun before you go out there, and you'll be set.
Okay.
But it might get washed out by the corona. The corona might be bright enough where you won't be able to see it. So, as totality sets in, a series of events happen as it's getting dark as night and the stars are coming out. A lot of people report these curtain-like shadows that ripple across the ground. I saw these.
Very interesting.
They were absolutely amazing. I'd never seen anything like it. It was like you're on the bottom of a swimming pool and you know how the light kind of plays and you see those shadows ripple?
Right.
Except it was everywhere, standing on the surface of the earth.
That's crazy.
It was absolutely amazing.
So we're going to see some crazy things at this eclipse.
You'll see some crazy things. Some people report feeling what they call the eclipse breeze, a slight breeze that sets in. And a lot of this has to do with the fact that it's going to drop in temperature significantly very, very quickly. Okay. Up to 15 to 20 degrees Fahrenheit in a matter of really seconds.
Wow, that'd be nice to have today, but...
Yeah, where I was, it went from minus 20 degrees Celsius to minus 30 degrees Celsius. So about minus 5 degrees Fahrenheit to about minus 35 degrees Fahrenheit, like that.
So that's colder than my home country of Canada. That's pretty cold.
That's pretty dang cold.
Okay. So, you went up to Norway, near the North Pole, to see this eclipse. And we're going to... Hey, what about animal behavior during eclipses? I've heard a lot about that animals are going to think it's nighttime. Is that...
So yeah, that's exactly right. Animals will begin to think it's nighttime. And the way I always like to say this is during a total solar eclipse, animals start to behave very strangely. Birds will start to nest. Daytime animals will go through their bedding routines. You might start to hear the crickets chirp as the nighttime creatures start waking up and they think it's night, so they start doing their nighttime things. So the animals are confused and acting crazy. Not only that, whenever I say animals, it's really important to include humans in this, because humans really start to behave very strangely during the total eclipse.
How so?
And this is where I put...
Is that making it turn into a werewolf or a zombie or anything?
You will first be a werewolf, then you'll be a zombie, then a vampire for a brief second because you can be out in the sun.
Right.
But no, none of that really. And really, I think this comes down to the fact that this is one of the most beautiful natural phenomena you can ever witness. And it is totally unreal. The way I describe my personal experience, and I hope everybody else has something similar, I think it's really hard not to, is when totality set in, it's like I got ripped out of reality and thrown into a dream world. What was day is now night. What was the sun in the sky is now this black disk. It looks like there's a hole in the sky where the sun is supposed to be. And not only that, it's surrounded by that white, softly glowing, effusive light of the corona. Truly an extraordinary experience that's outside of reality. So this really felt as if I'd been ripped out of normal reality, tossed into some weird dream world that doesn't make any sense in a matter of seconds.
Okay, so you said people are going to behave strangely. What kind of things are people going to do?
They will be gawking. They'll not be able to make sense of what's going on. It's not like we're all going to like get out and start dancing jigs or like scream and run around. Some people might do that. I highly doubt it. But it's really, they start behaving strangely because they're dealing with an experience that they've never experienced before.
Okay. So no one's going to go nuts, probably.
Nobody will go legitimately nuts.
Let's hope so. We're over here looking at some of these pictures that you took from your experience in Svalbard. Is that what you said?
Svalbard. S-V-A-L-B-A-R-D.
Okay, so very Nordic there. In the upper right-hand corner here of this picture frame.
This one right here?
Yeah.
Yeah, so that is just at the start of an eclipse. And this is what you should expect to see during the beginning of the eclipse.
Okay.
We actually call this the ingress. That's whenever the moon is first starting to cover the sun. It's on its way to totality. And you can see here we're actually seeing the moon. It's dark, of course, because it's a new moon. We're looking at the night side of the moon. And it looks like it's taking a bite out of the sun. Okay. As time progresses, the moon will pass further and further over the sun until you're left with just a tiny bit of a crescent of the moon. This one is oriented slightly differently. That's due, this is my mother that created this, and she did not orient the pictures to the correct.
Shout out to Tammy Lindsay on that one.
A big shout out to Tammy Lindsay. Tammy Lindsay, my mother, without her, I would not be here.
What a nice boy.
So really, all the credit goes to her.
Thanks to
not to me.
And for all those sweet frozen pizzas back in the day.
Oh yeah, and burritos. Don't forget about the burritos.
I loved them.
And a shout out to Schwann's.
Big shout out to Schwann's. What's up, Schwann's? Send us some stuff. No, but so you go down to this one in this lower left.
That's better. Okay. So as the eclipse progresses towards totality, the disk of the moon is now covering up almost the entire disk of the sun. Here, we're just minutes away from totality.
Okay. And then we'll have totality down there next to it. We looked at it, and that's the corona, that white light that's around it.
Yes.
Okay, fantastic.
So a little bit about the corona and totality. So as I was saying, the corona is the outermost atmosphere of the sun. It's super hot plasma that's just not a whole lot of it there, so we can't see it during the normal daytime. The day is too bright and washes it out. We can only observe this during an eclipse, and you can see that there's a little bit of structure in the corona itself. You see that there's like these weird lines coming out of it, and really the corona, being a plasma, reacts to the magnetic field of the sun. It reflects the shape of the sun's magnetic field. So the sun's magnetic field is constantly changing. It's a very complex thing that we are, as astronomers and heliophysicists, are trying to understand. It's one of the bigger mysteries of our solar system, is understanding the sun's magnetic field. It's constantly changing, so that means the shape of the corona is constantly changing, which means every eclipse that's observed is a unique corona arrangement.
Okay, so that's why it's such a big deal to study the corona, and why people want to know about it, so they'll learn more about the sun's magnetic field.
Exactly, and one of the things they're going to be doing is there is a network all the way across the continental US that people will be making observations. For the shadow, the umbra of the moon, to go from Oregon all the way to South Carolina takes about 90 minutes. So this is going to give an opportunity for that network to observe how the corona is changing on timescales of 90 minutes. So how it's fluctuating very close, the inner part of the corona, over a 90-minute time frame.
So you can build a better database of knowledge, so you'll be able to make better estimates.
Correct. So we will be able to see short timescale changes on the innermost parts of the corona.
And you'll be able to extrapolate those into larger ones, should you so choose.
Right, and we'll be able to extrapolate that really into how the sun's magnetic field varies in general on short time scales, which will dictate the behavior of the sun on shorter time scales.